Okay, so are we ready to go over what we're doing today? Huh? What are we doing today? We are multiplying and dividing fractions now. Multiplying and dividing fractions. Multiplying and dividing fractions. Okay. So, here we have something like this. 7/8 times 1/2, aka 1/2. So, in the adding and subtraction world, we were supposed to do what? Find the common denominator. That's the rule with adding and subtracting, right? When multiplying, what's the rule? Does anyone know the rule? Does anyone know what to do? No? Just multiply across. What's 7 times 1? 7. What's 8 times 2? 7 is one of those fancy numbers in which you know it ain't divisible by anything except 7. But is 16 divisible by 7? No, so guess what? This is the lowest term. So, there you go. That's how you multiply fractions. You're done. Wow. So, the rule with multiplying, multiply across. Easy peasy. You getting out? Okay. Do you want this? Diane? Diane, do you want? You can at least turn it in tomorrow, yeah. Quiz tomorrow. 6:20. 6:20. So, the rule with multiplying, multiply straight across, right? That's literally all. That's literally all. Seriously. And then yes, always check whether this could be simplified, all right? Always check whether it could be simplified. So what's the other thing you got to watch out for with multiplication? Well, not watch out for, but deal with. What's a helpful trick? A helpful trick, let's see whether I could create one. No, I'm just going to copy this example. That's a good example. Okay. What's the rule of multiplying fractions say? Multiply across. So, 3 times 6 is what? 18. 2 times 5 is? 10. Okay. You could convert to mixed number right now, but I'm pretty sure you guys could see that this could be reduced right off the bat, right? But, blah, 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 blah. Forget. Let's try reducing this. What is, use the 2 trick. Some of you probably already know what number it could fit in, right? Oh, actually, yeah, it's going to be the same number. But for you beginners, if you wanted to learn how to simplify, just get familiar with always dividing by 2 and then up, if in case either one comes out of decimal. What's 18 divided by 2? 9. What's 10 divided by 2? Okay, there's my answer. You now just have to convert to mixed number. Am I right? But scratch all that. Before I even convert this to a mixed number, oops, I shouldn't do that. Do you see what I did here? I had to simplify, right? Simplifying is easy, but when numbers get big, right, simplifying can be a little tough. Such as 112 over 56, right? It could be a little tough. And that, my friends, is the problem with multiplying straight across, right off the bat. Sure, you could always do that and then get a number and then reduce it, but there is a trick when multiplying fractions. And it's this right here. Spotting, or I should say simplifying right off the bat. What you always want to do is check your cross fractions. So there's a 3 and 5. So put it down below 3 and 5, right? And then ask yourself, could 3 and 5 be reduced? Like if you were just to been asked 3 over 5, could you simplify 3 over 5? No, you cannot, right? Because again, 3 and 5, they are both those unique numbers that are only divisible by themselves. But then do that not just with that one, do that with the other one. And ask yourself, can 6 over 2 be simplified? Yeah. What could it be simplified to? If you divide both by 2, you end up getting 3 over 1, right? If you spot this right here, that one of your cross fractions could be simplified, what you literally do, you guys, is rewrite this like that. So now it's 3 over 1 times 3 over 5. You see that? Do you see that? Now you multiply across. What's 3 times 3? What's 5 times 1? Is that what I got before? Yeah. Now you might be asking, why do I want to do that? Why do I want to do that? Why do I want to do that? Well, again, example, those big numbers. I guess I should show an example of this. But if you were to have big numbers and you were to spot that right off the bat they could be simplified, do it right then and there. That way your answer immediately comes out simplified. There's no need to simplify your final result from a multiplication straight across. Now somewhere in here I have an example of those big numbers, but I can't seem to find it right now. I can't seem to find it right now. Seems confusing. Does it? Okay, let's do another example, because we must learn this. Yes, yes, you read my mind. A mixed number. So obviously, we have something like 2 1/3 times 3 2/5, right? What is the rule that I'm laying down for this class? No, in terms of mixed numbers. Operations involving mixed number fractions. What's the rule that I'm just telling everyone for now on to do? You convert each mixed number to improper fraction. Trust me, it'll make your life a lot easier. But yes, you have to deal with big numbers when you do this method. But luckily for us, we are masters at multiplying and dividing by hand. So we could deal with it, all right? So what is 3 times 2? Plus 1. Okay, 7 over 3. Times, what is 5 times 3? Plus 2. Right? Ooh, this is not a good example. Dang it. I told you. Okay, one more example. You ready? One more example. Which example? What are you talking about, Chris? No, I want to find a really, really good example. Okay, so we're going straight to the next thing because that's going to give us a good example. What happens if you have a division fraction? 4 over 3 divided by 11 over 12. Does anyone know the rule with dividing fractions? Yeah. I saw the motion. I saw that motion. I'm like, I already know what you mean. So when dividing fractions, what we want to do is do this. Let's do that. Just constantly do this. And then the answer comes out. No. What we want to do is look to the second fraction. And what we do is we flip them. So this becomes the new problem of 4 over 3, 12 over 11. The thing is, why do we flip them? We flip them to convert this division sign to a multiplication sign. So pretty much, technically, divisions doesn't exist. We flip and then we just deal with multiplication every single time. Every single time. Flip the second one and then multiply. So now, this is somewhat of a good example of what we were doing last time. You could do 12 times 4 and 3 times 11. Abraham, walk on in. So, if we were to multiply straight across, this is a good example right here. What is 4 times 12? What is 11 times 3? Do you see how 48 over 33, for a lot of people, it could be somewhat intimidating and somewhat difficult to start the simplifying process? Are both divisible by 2? So then they have to move up to 3, right? And then from there on, they have to see whether that could be simplified. And that, and then, right? That's why when multiplying fractions comes the trick that I taught you, is take literally 30 seconds off of your time, literally not more than 30 seconds of your life, and just check your cross sections and check whether they could be simplified. Can 4 over 11 be simplified? No, because guess what? 11 is one of those unique numbers that you guys should memorize that cannot be simplified other than by itself. That's what, 10 seconds off my life taken, just checking the 4 over 11? How about we check the 12 over 3? Could the 12 over 3 be simplified? To what? 4 over 1, right? Look at an additional 10 seconds of your life. And we just, now what we can do is literally erase that 12 and substitute it for a 4. We could erase this 3 and substitute it for a 1. Now multiply across. What is 4 times 4?
16.
What is 11 times 1? Could 16 over 11 be simplified? No. Because of that 11, right? Look at right off the bat, you found your answer. Right off the bat. It's sort of this comfort feeling, knowing that if you were to change one cross fraction, you could feel comfortable enough to say that whatever your answer is, it's reduced version. That's the benefit of checking your cross fractions and checking whether it could be simplified. What? Yes? Oh, yeah, I was getting there. Good. So, yeah, I know, but I was showing an example, all right? I was showing an example. In fraction world, your answer is not finished. It could be as simpler as it could get, but what must you always do in case your numerator is bigger than the denominator? always convert it into a mixed number, which is dividing. What's 16 divided by 11? How many times does 11 fit into 16? Leaving a remainder of? I can't believe earlier in the day I was just like stumped when we came across that. When all I had to do was look at my three numbers. The whole point of converting to mix is that you will never have a remainder of 0. So you get your three numbers and you make it into your mixed fraction, which in this case ends up being 1, 5, 11. That's your answer. Cool? I mean, honestly, if push comes to shove, when multiplying fractions, you could just multiply straight across, right? If you guys want to just throw that whole simplifying thing out of the way, you're kind of making it difficult for you, a little bit difficult, unless you're like that with your multiplications in your head. But if push comes to shove, how do you multiply fractions? You just multiply straight across, right? How do you multiply division fractions? You flip the second fraction and make it into a multiplication problem. It's just weird. Weird, yes, but do you understand it? Now you know what to do? You flip it. You ever see a division in between two fractions? Flip the second set. Make the division into a multiplication. Multiply across. Or, if you want to save yourself a little trouble, take 30 seconds out of your life to spot the cross sections and check whether right off the bat you could simplify it. So, multiplying fractions, we now know. How do you multiply mixed numbers? We now know. You always convert it to an improper fraction. That's the new rule that I'm setting, just so that all you could gain and get the habit of doing that, right? How do you divide fractions? Easily. Flip the second fraction, make it a multiplication problem. Any questions? Well, let's see if there's anything that you must watch out for. The only other thing I could see on the practice problems that you guys might be, for some of you, be a little surprised about is if you're ever given a whole number. Do we know what we got to do here? The whole number is always over 1. Get it? Got it good? Multiply across. And in this case, if you did take the time to check whether they could be simplified, you realize they can't. So then, by default, you have to multiply across. Alrighty. I think we're good. I think this was a really productive lecture. I think all of you have learned something. Right? Yes. So, let me hand out the practice problems.